So, welcome to our next session that will explore automating threat analysis and risk assessment using the openXSAM format to improve cybersecurity across the automotive supply chain. This approach enhances data standardization, interoperability, and compliance with ISO CY 21434 and UNR 155. And welcome, join us Sergio, Cybersecurity Manager at ZF Engineering Solution, with over 35 years of experience in automotive engineering and cybersecurity. Welcome, Sergio, to the stage.
Thank you. Okay. Good morning, good afternoon, good evening, everyone. It's a pleasure to be here at Secure Streets Conference 2025. I'm delighted to share my research in automotive, threat analysis and risk assessment, or TALA for short, and how we can improve data sharing using the, for example, openXSAM format. If you work in automotive cybersecurity, you know that the cars are no longer just mechanical devices. They are connected, software-driven, and deeply integrated into digital ecosystems that give us new capabilities, but also expose us to new risks. And then over the next half hour, I will walk you through the problem we are facing, the research I have conducted, and insights from industry professionals, and practical recommendations for improvement. I will also touch on how automation can make TALA more effective, accurate, and consistent. Okay, before we begin, a quick word about myself. My name is Sergio Escobar, and I'm a cybersecurity manager at ZF Engineering Solutions, and I also finished my master's in computer science with cybersecurity at Wexford Glyndŵr University. And today I'm here purely on a personal capacity, not representing that group, to share my academic research that I believe has a real world value. And if you'd like to connect after the session, my LinkedIn profile is on the slide, also on my profile here. And let's start with introduction to automotive cybersecurity. Modern vehicles are incredibly complex cyber physical systems. They rely on dozens of ECUs and millions of lines of code to deliver safety, performance, and convenience. This complexity also means a much larger attack surface. Cybersecurity breaches can compromise not only data privacy, but also physical safety. That is why standards like the ISO SA 21434 and the UNECE Regulation No have become essential. They require manufacturers to implement robust cybersecurity management systems as part of the type approval, and compliance is now a global reality. Let's start with the research hypothesis and question. The hypothesis guiding my work is very simple. Automating the conversion of data to the openXSAM format will significantly improve the efficiency, accuracy, and standardization of cybersecurity data exchange in automotive industry, enhancing compliance with international cybersecurity standards. And for that, I have developed the three key research questions. How can automation of data conversion to openXSAM be effectively implemented in the automotive industry? Where do the current limitations in openXSAM format hinder the widespread adoption, and how can this be addressed? And last but not least, what insights do the industry professionals provide about the practical challenges and benefits of automating data conversion processes? Now let's see the literature review with TALA methodologies in automotive cybersecurity. And Tala has become a cornerstone in automotive cybersecurity due to the increasing complexity and connectivity of modern vehicles. Various methodologies have been developed, yet many face challenges and when addressing the dynamic nature of cyber threats. However, my literature review revealed some recurring issues. First, many approaches don't adapt well to changing threats. Scalability is also an issue, particularly for real-time applications. Some methods are resource-intensive and limiting adoption by smaller organizations. And integrating Tara into rapidly developing cycles remain also a challenge. Let's continue with the gaps in the current Tara methodology. 4 gaps really stand out. First is the lack of empirical validation. Existing methods often lack a real-world validation, creating a disconnect between theory and practice. Narrow focus on external threats. Current research overlooks internal threats, such as a compromised software components or cyber threats. Fragmented approach. The Tara practices are often isolated from other development activities, failing into account for interconnected vehicle systems. And the last one is limited anticipation of emerging threats. Current methodologies struggle to anticipate threats and related to the new technologies like autonomous driving or V2X communications. And these gaps are important because they are exactly where the attackers would get in. And after the Tara methodologies, let's see now how the data standardization challenges. The standardization aims to create a common language for cybersecurity data. OpenXSAM is one of such languages. The benefits of standardizations are clear: easier collaboration, faster data exchange, more reliable results, but obstacles are significant. Legacy systems, the industry reliance on legacy systems and proprietary data formats hampers the seamless adoption of new standards. Diverse stakeholders, the automotive supply chain involves numerous stakeholders with different data management practices and cybersecurity requirements. Inconsistent implementation, even when standard formats like openXSAM are adopted, inconsistent implementations practice leads to interoperability issues, and hard integration complexity. Integrating standards data formats which with existing hardware components creates vulnerabilities that are difficult to detect and mitigate. And let's finish the literature review with data conversion methodologies. And converting Tara data from proprietary formats to standardized formats presents significant challenges. Current approach includes machine learning techniques that map data fields between formats. Hybrid approaches combine automated tools with manual oversight, and frameworks focus on maintaining data consistency and accuracy. However, these approaches face limitations: dependency on large training datasets, resource-intensive process, lack of standardized testing protocols, and risk to data integrity during the conversion. And in a nutshell, what we have is machine learning mapping, promising but requires huge data sets. Hybrid approaches, accurate but labor intensive, and framework-based methods, consistent but lacking universal acceptance. And all of them with risks to data integrity during conversion, and which has pros and cons, and none are yet industry standards. And for my research methodology, I have used a convergent parallel mixed methods design. That means that I collected both quantitative and qualitative data at the same time, analyzing them separated, and finally merging the results. The quantitative data came from a structured online questionnaire with 22 questions distributed to professionals in automotive and cybersecurity industries. And this was done last year from October, November. Quantitative data come from extensive review of academic papers, industry reports, and technical documentation, and the data analysis using the extensive review of academic papers, industry reports, and technical documentation, and comparing them, I could identify where numbers and narratives agree and where they didn't. And let's see now the results, and starting with the survey demography. The survey includes 13 professionals, about 1/3 from Tier 1 and Tier 2 suppliers, a quarter from OEMs, and the rest from consultancies, universities, and other sectors, and over 75% worked directly on cybersecurity, ensuring that the responses are grounded in real-world practice. Okay, now we can move to about the TARA implementation and familiarity. We can say that familiarity with ISO SAE 21434 and UNECE Regulation 155 average 4.43 out of 5, and perceived effectiveness of TARA was lower at 3.67, and coverage of both internal and external threats was 3.6. And while industry professionals are highly familiar with relevant standards, there is room for improvement in effectiveness and comprehensive coverage of TARA methodology. The top TARA challenges cited during the survey are gathering accurate, relevant data, cited by 56.7% of respondents, limited access to a skilled person, with 43.3%, complexity of risk scoring and prioritization, 40%, and challenging to keep up with rapidly evolving threats and landscape, with 33.3%. These are process and resources challenges that can delay projects and reduce quality. Time-consuming aspects of TARA, when I look to them, we can see data gathering against the top list with 56.7%, cross-functional coordination with 50%, updating TARA with new threat intelligence with 43.3%, threat modeling itself 30%, and identifying scenarios and risk scoring, both with 26.7%. The most time-consuming activities are also the ones that people find most challenging from the previous slide. That's a key insight for process improvement. When asked about the importance of data standardization using formats like the openXSAM, the average rating was 3.87 out of 5. The distributions of the ratings are very important, or 5, with 43.3%, and important with 4, with 30%, neutral with 3.3%, less important with 6.7%, and not important with 6.7%. Means that 73.3% say that it was important or very important. That's really encouraging, but it still leaves almost a quarter of respondents not fully convinced about data standardization. What are the challenges in data standardization? In terms of data, these ones, the top barriers are lack of universal standards. 66.7% cited the absence of universal standard or framework accepted by all stakeholders as a major challenge. Inconsistent data formats. 63.3% report inconsistent data formats used by different suppliers or partners as a significant barrier. Data integrity issues. 50% struggle with maintaining data accuracy and integrity across different platforms. Stakeholder resistance, 50% encountered resistance to change or lack of buy-in from some stakeholders in the supply chain. And these challenges highlight the multifaceted nature of data standardization issues in the automotive cybersecurity industry. When asked about the experience of data integrity or compatibility issues when sharing cybersecurity data across different platforms or stakeholders, 36.7% says that regularly experience issues, 33.3% occasionally encounter problems, 13.3% didn't experience any issues, and 6.7% not applicable to their contest. A significant majority, or 70%, have encountered data integrity or compatibility issues to some degree. That's a big number, and it shows why even the best data process can fall short by full data handling. When I asked how organizations keep cybersecurity data consistent when moving between systems or formats, the top answers are using standardized formats like openXSAM, 6% of the respondents, manual verification and quality checks, 56.7%, regular training for team members on data handling practice, 26.7%, dedicated teams responsible for data consistency, 23.3%, and rely on automated data conversion tools with only 16.7%. No formal process in place, 13.3%. And while standardized formats are the most common method, there is still significant reliance on manual verification, highlighting the opportunity for greater automation. Familiarity with openXSAM. And when asked about if you are familiar with the openXSAM format for data sharing in cybersecurity, 36.7% say yes, 20% say somewhat, and 43.3% say no. This indicates that while the openXSAM is gaining recognition, there is still a significant portion of the industry that is not familiar with this standardized format. And the next question or next slide will be about the openXSAM benefits and challenges were only answered by these 11 persons that say they know, they are familiar with this format. And this was the question. What's the benefits of the openXSAM? And among those who knows openXSAM, we can highlight the top 4 benefits. 100% of respondents familiar with openXSAM cited simplified data sharing and collaboration with suppliers and partners as a key benefit. 19.9% report on improving interoperability between systems and tools across the supply chain. 54.5% noted enhanced data consistency and accuracy in cybersecurity reporting, and 36.4% experienced streaming and data process when using openXSAM. Other answers that are not on this slide, but they are in my research, that is another 36.4% improving traceability and auditability of cybersecurity data. Another 36.4% easier compliance with industry standards, for example, ISO SA 20144 and R155. And 27.3% reports a reduced time and effort needed for data conversion, and also 27.3% a greater scalability for managing large volumes of cybersecurity data. And these are exactly the outcomes we want. So the challenge is how to increase the adoption of the openXSAM or any other format. Then we go to the automation of data conversion. And respondents rated their belief that automating data conversion can significantly improve efficiency with an average of 4.07 out of 5, indicating strong confidence in automation's potential benefits. Yet current practices are mostly manual, 53.3% with manual conversion, 46.7% with custom building scripts or tools, 30% have no formal process, and 20% using the third-party software, and dedicated teams only used by 3.3%. And the reliance on this manual process and custom building tools highlights a significant opportunity for standardized automation solutions in the industry. And this leads to my conclusions and recommendations. To sum up, my conclusions and recommendations are develop a robust automation tool, creating user-friendly tools for automated data conversion that supports multiple input formats and include automated validation. Promote industry-wide standardization. Encourage broader adoption of standard formats like the openXSAM through the industry collaborations and educational initiatives. Provide training and support, addressing the resistance to change through comprehensive training programs and support resources for implementation. Enhance security measures. Develop robust security protocols to address concerns about data confidentiality during conversion process. And by addressing these challenges and delivering automation protection, the automotive sector can enhance cybersecurity practices, improve compliance with international standards, and create more secure vehicle streets, securing our streets. And I finish with this one. The data is essential, but only as good as the data behind it. Standardization is the foundation, automation is the accelerator, and collaboration is the glue. And thank you for your time, and happy to take your questions now.
Thank you very much, Sergio. It was very interesting. So we have several questions from the audience. So let's start with this one. Which tools do support openXSAM?
Currently, the tool that I know that is supporting the openXSAM is the item secure. I don't know any other tools that can do that. And I know what the component that I work that we also have a script that can export to or import the openXSAM to the Excel format.
Thank you. Can openXSAM be used to link Tara results with penetration testing evidence, like test cases and findings?
I believe that the version 1.0, the current openXSAM cannot be directly used for that. I'm working in a working group with ASRG on the new format of the openXSAM or the RDX, and one of the use cases is the sharing results with testing guys to create test cases. And means that we are considering this for the new version, but I don't believe that can be directly used. You can take out the pieces of the data, like the cybersecurity goals and cybersecurity controls, and make it some a link to the test cases for penetration test, but it's not directly linked.
Thank you. Has the survey audience work at T1 or T2 or T3?
The survey audience was tier 1, tier 2, and I didn't remember because it was anonymous. I just make a question. Are you working for tier 1, tier 2? I don't know if tier 3 was there, but we had OEMs, tier 1, tier 2, university, and consultancy companies on the respondents.
So it's quite wide audience from different.
Yes.
Great. Okay. Given the rise of AI-driven cybersecurity management tools, do you think the industry should focus its resources on building the dedicated platforms for cybersecurity management to automate Tara, or invest heavily in migrating legacy data into openXSAM?
Thank you, Mike. It's a good question. My answer will be, if you have enough data, legacy data that can be used to create your own data tool, that can be trained, AI can be trained with your own data, this is a good direction. But always try to keep your data exchangeable with OEMs and suppliers. Any data tools that you create, you should have a way to export and import other data. But if to create AIs, you need a large amount of legacy data, and if you have this legacy data, use them.
So you need the kind of interoperability in this case between Tara Excel, openXSAM, yes, and your AI tool.
Yeah, in the end of the day, to train the AI, we will need some markdown And the best way to create this markdown is the exchangeable formats. Then if you have data from different tools, made in different tools, you can put on the same level, exporting all of them using the same format, for example.
Oh, thank you. In your opinion, the reported advantages are from practical experience or just anticipated?
The reported advantages are practical experiences. I have standard via my LinkedIn the questionnaire and survey, and I know many of the guys that report, I say, yes, I answer your question. I know that they're using, for example, item secure or security analyst that covers the openXSAM, and then mean that it's more from practical experience or just anticipated.
Thank you. Additional interesting question. Can Tara openXSAM can be linked to different vulnerabilities or in general external databases?
I believe that the openXSAM no, but the new format, the RDX that we are working, yes, because the RDX can be, we are deciding to use the Cyclone DX that is linked to the S-bones, that can also be linked to the vulnerability. And this is the new version can be linked to the vulnerabilities and external database.
So theoretically, everything will be linked together. So
Yes.
How can openXSAM be leveraged to share the analysis of certain incidents and vulnerabilities? I think it's kind of plus minus the same as previous question.
It's a good question, and we have discussed internally this one. And the question is, if you have incidents or vulnerabilities, the first thing to do is try to see if you have the data for the project. But depending on the case, the data was done far away, or you don't have the data right to you. And the recommended is best practice is create your Hadoop data or a data of your incident and make the ratings there. And the openXSAM can be used if you have saved this data and given to the incident team or the team that's taking care of the long-term support. If they have access to the openXSAM, they open an Excel format, for example, import, and they can see if the incident was already treated or if it's a new vulnerability or a new weakness on your project.
Thank you. By standardizing Tara into a single file format, aren't we making the files themselves a high-value target, since attackers will know exactly what to look for, and it will become easier to parse?
This was another good question, and I know the openXSAM it's like a XML format, and the new version that you are working, that's a Cyclone DX. We also have a way to securify with digital signatures, also encrypt the files, and assure the integrity. And also there is standard formats of Cyclone DX to be exchanged because the same value of the data can be also the same value of the some contents of the S-bond. And this is we are just using what is already existing for Cyclone DX to protect the exchangeable format. Means that you can encrypt with a key and then share the key with your customer or OEM or tier one, and then only with this key you can decrypt the file.
Cool. And this is also a very good question. Do you have any materials to guide how to use openXSAM for Tara or kind of trainings?
Yes, we have. There is a manual. I can maybe John can put the link here, or you can send me the on LinkedIn later. I can also get the link. There is an openXSAM format or a specification available, and we are working on the new version that will be also available very soon.
So I probably can put it in the chat here if you have it.
Yeah. If you have the link, I'll put it in the chat.
Yeah, that will be great. So it's can help. Once shared across the supply chain, these files effectively turn to new critical assets that need to be essential protection of the systems I described. So it's pretty correlates with previous question, I think, with key protection and how you provide from tier one to OEMs. think you answered this one.
I don't know if I got right the question. Once shared across the supply chain, these files are quickly turned into new critical assets that means the same level of protection of the system we described. If you receive something from your customer, it doesn't matter if it's a data or exchanging data or a specification, you need to have a document classification, strictly confidential, and we have security measures to exchange data, prefer to have face-to-face meetings, not sharing of the screen or not sharing of non-encrypted and so on. But I believe that it's the same question that you can make to any specification. If the customer give you the DBC file, if the customer give you a specification of the algorithms that they're using to secure some parts of the ECU, it's the same level of security that you need to have on this one. It's just another document that you need to take care with same level of confidence or protection.
Okay, and this is also a question talking about somehow this, but in another flavor, like how you separate the different levels of confidentiality between OEMs and tier ones.
The confidentiality levels is not included there. I know that some softwares offer functions like obfuscation that you can hiding the text, but you still can see the model to exchange with the tool vendor, and then we are not giving the knowledge to the tool vendor, but you ask it why the result is not as expected. It means that you are just encrypting the text, but the model is already there. I don't know if this applies. I know that if you go a little bit deeper to the new standards like the TAF, the target attack visibility, it's something that the OEMs will share with the tier ones and tier twos. And this is something that you need to receive it from the OEMs, and we need to take care and implement the TAFs. And currently openXSAM is not supporting TAF. A new one will be at least prepared to support TAF also.
And the last question we have, build a TAR management tool. Should I integrate the test case mapping feature in tool? It makes easier for pen tester testing attack path from TAR result.
I would recommend yes, creating test cases or linking test cases or saying that this test can verify this cybersecurity goal. It's a nice feature. Can be done inside of the TAR tool, can be done outside of the TAR tool. But if you can offer this feature, it's interesting. Again, the current openXSAM is not prepared for this one, but the new one will be.
Thank you. And thank you again, Sergio. It was a very interesting talk. If you want to join Sergio for additional questions or discussions, you can go to Lounge and meet Sergio there, and he will be happy to answer questions. Thank you again. Have a good day.
Thank you.